So here's some notation you may not have seen before. This notation, we haven't done a problem like that yet. All that means is y primed. It means you're finding the second derivative. You may not have seen it in that form with the d's there, but that doesn't mean squared. It actually means you're taking second derivative. So I want to find the derivative of y dy dx first, and then I'll take the derivative of that, and I'll get me this answer here. Let's first start by finding dy dx. We're going to do that implicitly. Now this is actually one of those rare problems where you could actually bring the x over, solve for y, take the derivative of both sides, and you could do that. However, it says use implicit differentiation, so that's what we're going to do for this particular problem. Okay, so when we do that, we're going to do the derivative of each of these terms separately. Anything that has an x in it, we're going to do normal derivative. 3 comes down, I have 3x, subtract 1, so you get 3x squared. This one, that's going to require us to do a chain rule. So the 3 is going to come down. I have y, subtract 1 from the exponent, I get 3y squared. Don't forget about the chain rule. We got to do a derivative of y, which is going to be dy dx. So don't forget about that part. On the other side, the derivative of 8 is going to be 0. And now we just need to solve this for dy dx. We're going to move the 3x squared over to the other side. So we have 3y squared dy dx. And this dy dx, that's the first derivative, okay, that we're trying to solve for now. Subtract the 3x squared over and you get negative 3x squared there. You need to solve for dy dx, so I'm going to divide both sides by 3y squared. And then that's going to allow us to find the first answer for dy dx. The 3's are going to cancel and you get negative x squared over y squared. So that's the first part of it. That's the first derivative. So now let's solve for the second derivative. We found the first derivative. Now let's find the second derivative. To find the second derivative, we're going to take the derivative of this. So because we have a fraction, that means we have to use the quotient rule here. So I have d squared y over dx squared, the second derivative. Now we're going to apply the quotient rule. Quotient rule says we take the bottom thing times the derivative of the top. So I have the bottom, which is y squared. Now the derivative of the top, because it has an x, again, because you're doing this derivative with respect to x, if that variable here matches the variable that you're taking the derivative of, you can do normal power rule. So we're going to do negative 2x minus the top thing, negative x squared. Now we have to do the derivative of the bottom. So because there's a y on the bottom, we're going to do this implicit. So 2 comes down, y the first power, and then you're going to multiply it by the derivative of the inside. Again, that's that chain rule we mentioned earlier. Derivative of the outside, 2 comes down, derivative of y is dy dx. So bottom times derivative of the top minus the top thing, this whole thing is derivative of the bottom, over the bottom squared. So I have y squared squared in this case, because that's part of the quotient rule formula. It says that we have to square it. Let's clean it up. So I have d squared y over dx squared is going to equal, it's going to be negative 2x y squared, minus minus is plus 2x squared y dy dx. All this is going to be over y to the fourth power. What you can do here is you can divide each of these things by y to the fourth. So let's do that. Just break the fraction up into two separate pieces. I have negative 2x. Now I have a y squared. I'm dividing it by y to the fourth. That's going to leave me with a y squared on the bottom. We're going to do this one and separate it as well. You have plus 2x squared, and then this one, there'll be a y cubed in the bottom, and I'm actually going to write dy dx separately like this. You can do that. You can write it like that. Now, you could leave your answer as this one here, but what you can do is you can actually make a substitution. Instead of leaving your answer with dy dx in it, it's better to actually have your answer in terms of x's and y's. So since we already know what dy dx is, what we're going to do is we're going to just take out the dy dx, we'll replace it with negative x squared over y squared. So I'm going to make some space here so I can do that step to show you that one. Okay, so we're going to now take this and we're going to plug in the dy dx. So I have d squared y over dx squared is going to equal. Let's do this. We have negative 2x over y squared plus 2x squared over y cubed times the substitution we'll put in for dy dx. That's this over here, we found it earlier. Negative x squared over y squared. So now that we have that, we've put that in, we just now have to clean it up to get our final answer. So we'll do that here. D squared y over dx squared, that's the second derivative. Okay, is going to be negative 2x over y squared plus, when we multiply across the top, across the bottom with the fractions, this will become a minus. 2x to the fourth on the bottom. You're going to add the exponents together and you get y to the fifth. You could leave your answer that way, or you could also get common denominators. If you got common denominators, it'd be negative 2xy cubed minus 2x to the fourth over y to the fifth. If you wanted to put it back as a single fraction, you can certainly do so. So either one of these would be your correct answer, this one, or you have this one.